Mass percent composition. Sometimes it's helpful to express the composition of a compound in terms of a percentage instead of looking at a particular formula. And these sorts of things are more useful in experimentation and field work and things like that. So it's helpful to keep in mind what percent means. The percent is the part divided by the whole times 100. And if you can keep that in your head, you can figure out a lot of percentage things, because that's what percent means. So here we've got the mass percent of element X. It's going to be the mass of the part that we're interested in, which is X. So the mass of X divided by the mass of the whole thing. The part over the whole, then times 100. The unit on a percentage is always percent, because we've got mass divided by mass. Those units cancel out, and we get percent at the end. So let's do an example. A 2.45 gram sample of strontium reacts with oxygen to form 2.89 grams of strontium oxide. Use this data to calculate the mass percent composition of strontium in strontium oxide. So what do we have here? We've got strontium. Let's see if I can spell. And it reacted with oxygen. And then we've got this compound, strontium oxide. So this is the whole thing. And this is one part. And the oxygen is the other part. So I'm taking those words, and you have to have some reading comprehension to do these problems. And sometimes you're going to have to read it through a couple of times, get a mental picture or draw a picture or something, but figure out what on earth are they talking about. We're taking strontium, reacting it with oxygen. So we have two elements, and they're forming a compound. And we're talking about a percent composition, so that's going to be the part divided by the whole times 100. So we're given a number up here, 2.45 grams of strontium. So we know we've got 2.45 grams of strontium. And it says that reacts with oxygen, doesn't tell us how much oxygen, and we've got 2.89 grams of this product. The question is mass percent of strontium. So percent strontium will equal the grams of strontium divided by the grams of the compound times 100%. So the part is 2.45, the whole is 2.89 times 100, 2.45 divided by 2.89 times 100. 3 sig figs, 84.8% strontium. That tells us that for this compound, 84.8% of the mass is from strontium. The rest of the mass is from oxygen. Any questions? The part over the whole. This question was nice because they gave you the part and they gave you the whole. They don't always do that. Sometimes they give you two parts, or they give you the part that you don't need, and you have to figure out the part that you do need. Mass percent composition can be used as a conversion factor. And that can allow us to convert between grams of a constituent element and grams of the compound. We just did that using moles, but it was a 3-step process. It was a little awkward. If we know the percent composition, we can do a calculation like that much easier. So here we're told the mass percent composition of sodium and sodium chloride, and we're slowly getting back to that initial question, is 39%. (39 grams per 100 grams). Percent. Per 100. 39%. 39 grams per 100 grams. That's what percent literally means. So anytime you see a percentage like this, you could write it like this and use it as a conversion factor. Here they've written it out as a ratio. 39 grams of sodium to 100 grams of sodium chloride. If you have 100 people and 75% are boys, then you have 75 boys for every 100 people, right? So here's that question again. FDA recommends that adults consume less than 2.4 grams of sodium per day. How many grams of sodium chloride can you consume and still be within those FDA guidelines? Sodium chloride is 39% sodium by mass. We can use that percentage as a conversion factor. So we've got 2.4 grams of sodium. That's the maximum that we want. We want to find out how many grams of sodium chloride would that be. So we're going to multiply, and we're going to just put our units in using dimensional analysis. We want grams of sodium on the bottom. We want grams of sodium chloride on top. So the units cancel out. 39% sodium means 39 grams of sodium per 100 grams. So 39 grams of sodium per 100 grams of sodium chloride. 2.4 times 100 divided by 39 equals 6.2. 2 sig figs. .2 grams of sodium chloride. That would be a lot of table salt to just sit down and eat. There are other ways to solve this problem. Some of you may have learned other ways of doing percent calculations, and that is absolutely fine. You go right ahead and do that. But understanding percentages is something that can help you out in real life. Because you go to the store and it's 50% off or it's 75% off, and we run into percentages all over the place. Any questions?